Hello again. So what we're going to talk about today again is compound interest, but we've talked about compound interest tables and we went through that in the previous video. You could see that where the recursion part comes in, for example, that if you had the value here, it comes back here, and you calculate another one, interest on that value, you get a new value, you bring it back here, and that cycle continues. So now we're actually coming up to the compound interest formula. Okay, so what you might have seen previously in previous years is something in this form, where A was a final amount, P was a principal, R was a growth or compounding rate factor, and N you had number of periods. You had this other slightly modified version, or slightly different version, which accounted for that, that Rn up here. Now, that's not the terminology we're using. It's just basically the same equation we're going to be using, but we're using some different terminology here. Okay, so what we've got, because it's going to be done in terms of recursion equation, and the fact that you're going to get a recursion relationship. Okay, and so as a starting point, you basically, with your recursion equation, this is what you've got. You've got Vn plus 1 equals Vnr, where the Vn plus 1 is the amount of investment in one time period, and the R, the growth or compounding factor, which we talked about in the previous video, okay, is equal to 1 plus R over 100, where R is the interest rate per period. That's actually going to be quite important because we're going to get into that in a little bit more detail down here, but not just yet. So what we can see here is we can write it in terms of initial investment. So we can go from this equation here to this equation here. And what we actually do here is we say that Vn, so Vn here is essentially our next number, so our Vn plus 1, and our V0 is our previous number, if we're thinking about the recursion stuff we've done previously. And so what you end up with is you got Vn is your final or total amount, your V0 is your principal, and R is your growth or compounding factor. So I've said that before, that's your 1 plus R over 100. R is your interest rate per period, and I'm emphasizing the per period part here because that, again, I'm going to mention why in a moment. And N is the number of interest bearing periods, and again, I'm going to tell you about their relevance just in a moment. Okay, so I've made reference to the fact of the per period and a number of interest bearing periods, and the reason I'm making reference to those specifically is it relates here. So we're going to go to this nice arrow over to here, okay? And what it is the number of interest-bearing periods is the number of years times the number of interest-bearing periods per year, okay? So that's where it's got to be really, really careful with this, because if I say 5 years and I'm compounding quarterly, that means, for example, here, let's write it down. If I said N and I said 5 years, that means I type 5, and number of interest periods per year, if I said quarterly, that means 4. So that means I have number of interest periods is actually 20. And that's what you're using for N, okay? So this N here matches to that N there, okay? So it's important to really take note of that. I'm just going to try to get rid of, that's better. All right, but also, in addition to that, the interest rate per period, and this is R, so I'm going to use a different color. I'm going to go R here. That R is what goes here, okay? And what I say here, nominal interest rate per annum. So I might say an interest rate of 10%. Okay. So that means I go 10. And if I have number of interest periods per year, if I say quarterly again, that's 10 divided by 4. So what it's saying is my interest rate per period, so each quarter in my example, it's actually 2.5%. And that's the R you use per period, or the number of interest periods is N. That's what you've got to be really careful with. Really, really careful. Okay. Now, what we also need to take into consideration here is that the compound interest formula gives a total amount in an account, not just interest earned. It's got the interest. It's doing both. It's telling me that when I do the compound interest formula, it's giving me the total. So it's giving me how much I've got at the end. So it's saying how much interest I've earned. This is where this lovely formula comes in. So I say I equals Vn minus Vo. So my next value minus my previous value. Okay. So in other words, the final and total amount minus the principal. All right. And what we find here is we'll get if we were to plot this data, we get this lovely little curve that heads up like that. Okay. And as you can see, as a comparison point between the two types of interest, compound and simple. Simple, we've had a nice straight line going up, straight up. Whereas when we do compound, it's got more of a geometric response. Okay. All right. I might actually get rid of that because that sort of makes it hard to see. Because I was using green on green, not a good move. But you can see that there's a clear difference in the two types of interest. You can see that the compound interest will become increasingly higher compared to the simple interest. Okay, so let's now look at some worked examples. Okay. So let's look at this example here for worked example 7. So I've got $5,000 invested for 4 years at 6.5 per annum, interest compounded annually. So key points. Oops, let's come back a little bit bigger. 5,000 is my V0. That is my N. That is my R. And we notice that that's per annum, so that means per year, but it's actually compounded annually. So that means once a year. Okay, so in this case, we don't have to worry about this one here, okay, or this one here. So what do? Generate the compound interest formula for this investment. All right, so let's write the formula out first. So A, I'm going to go Vn equals V0, 1 plus R over 100, N. What's our V0? And we've got our things listed up the top here. You can list them out again if you want, but our V0 is 5,000. Okay. We've got 1 plus, what's our R? Our R is 6.5 over 100. And what we'd normally put is 4, but I'm going to put N. The reason I'm putting N because we just want to generate the formula for this investment. The reason I might put 4 there is because I know there's 4 up here, but I'm not worrying about that just at the moment. Then that becomes 5,000, 1 plus 0.065 N. And the way we want to write this as a final answer, 5,000, 1.065 N. This is the way you should be writing these answers. Okay. So now what I put in, it says find the amount in the balance after 4 years and interest earned over this period. 2 parts to the equation, to question I mean. First part, find the amount in the balance after 4 years. Second part, interest earned over this period. So be really careful about what the question's actually asking you. So let's go B. So B, what I need to do is, I know my time period is 4, so that's where I'm going to put n equals 4. And so I go V4, because that's what n is, 5,000, 1.065 to the power of 4. Then we get an answer of 6,432 and 33 cents. So that I'm going to highlight in the green. That's my, you can imagine this could be almost like a 2-mark question. I'm not saying it would be, but it could be, and that would be your first mark. But that's giving you your V4. So that's giving it what I've said in the green. The interest earned, remember there was this formula back here. Oops, no, this one here. Okay, that's the one we're going to use now. So we're going to go I equals V4 because that's my sort of next term, so to speak. What do they call it here? They call it, that's your final total amount. It's probably a better way to think about it. And that's my V0. So I've got 6432.33 minus 5,000. And I'm left with 1432 and 33 cents. So that's how you would, that's your answer for the second part. Okay. So that's the first part's giving you in the green, the second part's giving you in the blue. All right, worked example 8. So worked example 8, okay. Worked example 8, find the number of interest-bearing periods in N. So let's actually read the question fully. If 3,200 is invested for 5 years, that's my N, and that's my R, that's my V0. But here's a little kicker. Here's a little kicker. It's compounded quarterly. Okay. By the way, that should be an R. Okay. That's the little kicker that you need to be really careful of. Okay. So my N is no longer just 5. So let's go A. All right. So I'm after N. It's 5 years. Remember the equation. It's a number of years times the number of interest periods per year. So, and that means it's 4 quarterly. So it's going to be 5 years times 4. So let's highlight those in 2 different colors. That's that color. Let's put the 5 years as the blue, and that's the blue. Okay. So that's going to equal to 20. Okay. Part B, find the interest rate per period. Again, this formula now, interest rate per period. The nominal interest rate per annum divided by the number of interest periods per year. Okay, so B, my R percent per period is going to be 6%, that's per annum, divided by the number of interest rates, number of, what do we call them again? Sorry, interest periods per year, which was 4, and that's going to equal 1.5 per percent per quarter. Okay, so basically R is equal to 1.5. Let's highlight that again. I'm going to put yellow again because that matches up to what I had up there. Let's pick green for this. 6% per annum came about from this. Okay, so I'm going to run out of room here. So find the balance after 5 years. Okay, so let's write, in this one, I'm going to write the formula first. So I'm going to write this different color just so I can not confuse things too much. C, So it's Vn equals V0, 1 plus R over 100, N. So we know that our V0, in this case, is 3200. All right. Our Vn after 5 years. So that's where we're using this term here. That's what our N is. So we're going to say V20, 1 plus, and because it's per period, I'm using this 1.5%. Okay, so that becomes 1.5% divided by 100. And this N up here becomes 20. All right, that's looking a bit messy now. So let's actually get rid of that for the moment. Get rid of that, get rid of that. Maybe highlight some of these colors. So what's a color I haven't used yet? So the 20 comes about from here, okay? The 1.5, we can see there. So what it's basically doing now is V20 equals 3200. So write it always like this, good practice to get into. 20, because that's what the examiners are going to want to see. And then you put that into your calculator and you'll get a value of 430994. So my balance after 5 years, my balance would be 430994. Okay, so that's the way you can use it, because you've asked to find the number of interest-bearing periods, interest rate per period, find a balance after 5 years. That is how you find a balance after 5 years, using the recurrence relation. A slightly different way of doing it could be used to use Finance Solver, and it uses the same things we've got here. Okay, what it's saying here is our N, we've actually worked it out, that's 20. Our interest, it's 6. And the PV, that's the principal value, is 3200. Our payment 0, so it stays 0 because we're not putting any payments in. So you probably should have used Finance Solver before. I'll bring it up and show you how to use it. Our final value, that's actually what we have to find. So let's put a question mark there. And the part that says PPY, and there's one on below, I can screen clip that as well, is CPY. That's the payments per year. And because it's quarterly, that's 4. So if I go into, I'm in the calculate part, I go menu, finance solver, and let's actually write these numbers in. So, sorry, you're going to set a keyboard while I do this. It's 20. That's going to be 6. Sorry, that's going to be 6. The principal value, we know it's 3200. We don't have any payments. We skip FV for a moment because we're going to come back to that. Our payments per year are 4. And this is where we press enter. When we press enter, that's what we're calculating. And we'll get to the negative stuff later. So don't worry about that for the moment, but we can see that it's 4309. And that's what we had here. So you can actually use a finance solver as well for questions where it's asking you to do that. All right. So graphically represent the balance at the end of each year for 5 years. Okay. And you're thinking, how the hell do I do that? Let's get this into the right position. So let's escape out of that. I'm going to need to set up a listen spreadsheet. Let's bring this back over. Control I, listen spreadsheet. I'm not going to call it time. I'm going to call it time 1, just because I've used time this one before and it time 1. Okay. And what we're going to, we call this, let's call this AMT for amount. I hate when it does that. AMT for amount. So here we want to put 1, 2, maybe I should just call it time, to be honest, because I think it's calculated. T-I-M-E. T-I-M-E. Right. So I think it's got, I only need to, and the reason I'm going to need to put 2 more, because remember we had 20 not much luck at the moment. Okay, sorry I was a bit silent there for a moment. All right, so we're going. This is where we do it. Here's an example, not with the same numbers, but this is what we're putting in. So our number is going to be, for memory, 3200, and 1 plus 9 over 100. We're going to put 1 plus, well, let me see again, 1.5. So we're doing this. So let's actually put that in. So again, I'm going to put it over the side so I can see the equation. I'm going to go mostly the equation. Okay, so I've still got to be able to see stuff here myself. I'm going to go equals. Okay, I go 3200. I put times, no, make sure I put the bracket there. I'm going to put 1 plus, then I need my, this is one way to get this up. I need 1.5 there. And then underneath that value is 100. Then I go outside. I go to the power of, and that's what I had. That's what I go. This is where I type in time. T-I-M-E. Press enter, and voila. Ooh, you can see I made a mistake here. Okay, I need to do that again. Got to be very careful with what you actually write here. 3200. I must have times bracket. I'm actually just going to write 1.015. Then I'm going to go outside the bracket, and that's going to be time. And there must be something, I'm doing something wrong here because, I'm making a mistake here. Whoa, I hate when my computer plays up on me sometimes. Let's actually do that again. Sorry, this is taking way too long. 3200, oops, times, and that was 1.015, not 14, 15. I'm going to go outside the bracket. I'm going to go to the power of time and go enter. That makes more sense. Okay, sorry, that took way too much time. But you can see what I've got here is what I need, and that's going to calculate for you. And then I can do, let's bring that back over. I can do Control I, add data and stats, go time, go AMT for amount, and there we go. We've plotted the data for those 20 quarters. Okay. And if you had to comment on that, you'd be saying that the graphic's exponential as the interest is added at the end of each quarter, and the following interest is calculated on the new balance. Okay. Okay. Sorry, that last question went for a bit too long. We're just going to do one more work example because I know this has been a very long video as it is. Find the principal that would grow to 4,000 in 6 years if the interest is added quarterly at 6.5% per annum. So what we've got here, we've got our, that's our VN. This is our VN, okay? This is our number of years, but it's quarterly, okay? So our N is equal to 6 times 4, 24. Our R, we've said it's 6.5 per annum, but it's quarterly. So I go 6.5 divided by 4, okay? And that will give us 1.625, okay? Now, there's two ways we can do this. We can use it like I showed before with Solver, and I'll bring that up again. I'm just going to move this down so I can get some space. But let's put the numbers in for Solver here, and we'll calculate in a moment. So N is 24. My interest is 6.5. My principal value, that's what we're after. We just keep that as 0, so we don't have to worry about that. Final value, well, I know the final value, that's 4,000. And my PPY, my periods per year where I'm doing stuff is 4. Okay, we'll put that in the calculator in a moment because that's this is TVM. TVM. We can also do this as a solve because remember our equation effectively now is going to be V24 equals V0 1 plus R over 100 N. So that means it's 4,000 equals V0. That's what I'm after. 1 plus 1.625 over 100, 24. Now, if I want to get it in terms of V0, I've got to transpose it. I've got to move things across. Easy way to do it. Bring up, just go to calculator. I'm going to type in solve. There's instructions here, by the way. I find it easy to type in type in solve anyway, but you can find it follow it using the instructions provided. Again, something that's worth for a while having in your summary book. Have the brackets like that, and I'm going to type in 4,000. Okay, equals. I'm going to call it V instead of V0. V. They're going to multiply that by the bracket where it's going to be 1 plus where it was 1.625. This is going to be 100. I hate it when that happens. Damn. So that V equals, I'm not having much luck at the moment. Okay, times the bracket 1 plus 1.625 over 100. And I want to go outside that initial bracket and go up to 24. Then I want to come down because I want to go comma. And my comma here will be V because I'm solving for V. I'm after that V there, so I type V and then I press enter. And you'll find that the value is 2716 2716.73. So V0 equals 2716.73. That's my V0 it needs to be invested. Or if I put this in a calculator using things, so let's go menu, finance solver was 24. Oops, not 24. That was 6.5. That's what we're after. We'll come back to that. We don't change that. Final value is 4,000 with same time periods there. I want to go up to, that's what I'm after. Now I press enter. And we said the number is 2716.73, same as what we've got there. So we can use either TVM solver or the solve function to calculate to solve a question like that. Thank you.